it's going to take a while, so I'm going to go kind of fast. If I go too fast, you can just pause it and cut sections. But I'm trying to add up these three vectors. I need to know their horizontal and vertical components. So what I end up doing is making little right triangles out of these pieces. And so if I look at this little triangle here, it's got a hypotenuse of 12 miles, and I've got an angle here of 65 degrees. So if I want to know the length of this side, it's going to be 12 cosine 65. And it's cosine because it's adjacent. This side's adjacent to the 65 degrees. Now, up here, I have this is the opposite side. Well, opposite's going to pair with sine. Sine is opposite over hypotenuse. I have the hypotenuse value right here. So that one's going to be 12 sine 65 for that distance. This distance across here is just 10 miles. It's already horizontal, so there's nothing on top. When I get to this one, I've got this angle. This whole angle is 153. Well, I don't like that. It doesn't make a good triangle for me. I'm trying to work within this space right here. But one thing I do know is that vertical and horizontal, they make a right angle, which means I'm left with 63 degrees here, and then I just use the same logic as I did on the other side. My hypotenuse is 16 miles, so that's this distance right here is 16 miles. So if I want the adjacent side, adjacent uses cosine, so that would be 16 cosine 63. And then if I want the opposite side over here, sine uses opposite, so that's going to be 16 sine 63. And then I'm not going to go through and type all these in the calculator at the moment, just because I think it's going to take too long, make this video too long. But all of these values are going to determine my distances. So if I look at this one plus this one plus this one, they tell me how far it is between here and here. Okay, school's over. So I've got, let's see, I've got 12 sine 65, which is 10.8, 10.9 actually, so 10.9, plus this 10 right here, and then plus this piece is 16 cosine 63 is 7.3. And so altogether, this distance is 28. Actually, 28.2 on my graph. Full decimals. So we'll put 28.2. I'll just use those number values. And then I want to do the same idea going the other direction. I've got this 12 cosine 65. So this distance here, instead of this, I could say it's 5.1. And then over here, 16 sine 63. This distance is 14.3. Well, looking at how this distance is going to compare with this distance right here, they almost match up. So this is 5.1, and that means that the rest of this has got to be, let's see, it's going to be 14. It's going to be 14.3 minus that 5.1. I have to get that piece, this piece right in here. So let's see, 14.3 minus 5.1 is 9.2. So I know that this distance here, which is also right here, is 9.2. I don't know how clear that is. Hopefully if you go back and pause and rewind it, it'll make more sense. But at the end of the day, what we've ended up with is a triangle that has 9.2 on this side, has 28.2 on this side, and then we've got an angle theta in here, and we've got some distance d across here that we're interested in finding. So to figure out that distance d, that's just going to be the Pythagorean theorem. So I'll have 9.2 squared and 28.2 squared. So I'm going to type that in the calculator here. I've got 9.2 squared plus 28.2 squared. Square root of that is 29.7. And this is a minus. So that's how far the hawk needs to fly back. Now, the angle I'm interested in, just like in the last, a couple of the other problems we've done, I'm going to use tangent because I have, this is the opposite side, this is the adjacent side. So theta is going to be the inverse tangent of the opposite side divided by the adjacent side. Put that in. 9.2 divided by 28.2. The inverse tangent of that is 18.1. But notice the way the problem is written. It makes that part a little bit tricky. I'm going to take some of this out. Not that anyone's using it anymore. What we're saying is that this angle in here, this is the angle we found to be 18.1. And so what we want to do is subtract that from 1/8, because I know that this entire distance is 180 degrees. So that means that now this piece just right here, this has got to be 161.9. Because the angle we want is going to be 180 minus